we've already heard today that periodontal regeneration is a very important goal in our clinical activities. The goal is to restore the periodontal tissues which have been lost through periodontal disease, and the aim is to try to restore them to their original form, architecture and function. And this really is the restoration or the reformation of destroyed tissues and new attachments. We need to get newly formed connective tissue, newly formed cementum and newly formed bone. And this is actually a very, very complex area that we're trying to deal with. I can think of nowhere else in the human body where we're trying to bring three quite different tissues together in one place at one time with the expectation of regeneration. Because of that, the clinical outcomes, even though we do have regenerative technologies and techniques available to us, it is still fair to say that the clinical outcomes are sometimes quite unpredictable. And so because of the unpredictability, the field is a wonderful field to be involved in, and it's continually evolving. And one of the areas where it's evolving is the potential use of the role of stem cells as a regenerative agent. So this has led us into a new and evolving area of periodontal regenerative medicine. Now, we need to, in order to understand where we are and where we're going, we do need to also have a look at the history of where we've come from. And I think over the years, we've been very much taken with what I call the dental approach to regeneration. And that is, we see a hole in the bone, no matter where it might be, and we have this urgent dental need to fill it with anything. And those grafts and biomaterials can be any one of a number of things, some of which we've heard about already this morning, and they're basically just fillers that we put into a hole in the bone with the expectation of something happening. But when we really think about what we're doing, I just want to share a couple of quotes from the literature with you. And one of them is a concept that we began to develop in the early 2000s, was that to fill a defect, a periodontal defect, with a substance which has absolutely no relevance to the next functional stage of reconstruction is irrational. Now, it was meant to be a purposely inflammatory comment, and it was trying to make people begin to think, if we must put something into a periodontal defect, let's think about what the next rational stage of that process would be. We weren't alone. The Beckers at the same time also came up with similar comments, saying that as a profession, we've become obsessed with filling holes in bone rather than studying the natural healing process. So clearly, we still had this concept of having a hole in the bone, putting bone into the hole. It was just what we did at the time. But like anything in dental research, all new concepts are also quite often old concepts. And here's a wonderful quote from Caring and co-workers as early as 1984, and we all know how perceptive they were in their concepts of bringing periodontal regeneration to the clinic, where they state that ignorance of the contribution of the various tissue components of periodontal wound healing may explain the widespread use, and actually I would have said misuse, of bone transplantation in the treatment of intrabony pockets. And again, similar comments that regenerative treatment of periodontal defects with an agent or a procedure must require that each functional stage of reconstruction be grounded in a biologically directed process. So the stage was now set around the 2000 era that we really did need to begin to think about what we were putting into these periodontal defects if we really wanted to get regeneration. Now, it's important to understand there's two important definitions, I think, that we need to take on board when we're thinking about periodontal regeneration. The first is the term periodontal regeneration, and this is a biological term which is defined histologically as the reconstruction of tooth-supporting tissues involving alveolar bone, periodontal ligament, and cementum over the root surface, which has been deprived of the attachment apparatus. And the previous two speakers have shown us excellent histological examples of regeneration. However, there's another term which we really should also begin to bring into a lot more common usage in our clinical sense, and that's periodontal reconstruction. Now, this is a clinical term, and there's nothing wrong, but we need to understand what we're talking about. And this is a clinical term characterized by reparative and or partial regeneration, which results in the improvement of clinical attachment levels and pocket depths and radiographic parameters, but it's not regeneration. So when we are beginning to delve further into this field, I think we need to be quite clear in the terminology that we're using, are we talking about periodontal regeneration, which is the holy grail, or are we talking about periodontal reconstruction, which is fantastic in our everyday clinical practice, and we do achieve a good clinical output and endpoint, but we shouldn't confuse the two processes. So I think we've heard a lot this morning already about the biologic agents, the growth factors, some of the other extracts which are being used, maybe some of the fillers which are charged with biologic agents. So there's no need for me to go through those materials with you anymore, but move straight into what the topic of this presentation is, and this is the so-called cellular approaches and tissue engineering for periodontal regeneration. Now please bear in mind that a lot of the material I'm going to share with you is currently where the field is at. We still have a long way to go, but it's a glimpse maybe of what is going to be available to us at some stage in the future. Now, in terms of a cellular approach to periodontal therapy, we've known for some time now that clearly there are stem cell populations within the periodontal tissues which, given the right environment, the right growth factors, the right mechanical stimuli, have the capacity to differentiate into the three major cell types required for the formation of the periodontal attachment apparatus, which is the osteoblasts, the cementoblasts, and fibroblasts. And when we begin now to think of where we're at in terms of regenerative medicine, we need to understand that this concept is the process of replacing or regenerating human cells, tissues, and or organs to restore or establish normal function. And regenerative medicine, which is an emerging, very fast emerging area, refers to a group of biomedical approaches to clinical therapies that may, but not always, involve the use of stem cells. So just to help us understand what a stem cell is, these are the so-called master cells of the body. There are two major types. We've all heard of these. There's the embryonic stem cell, which has the capacity to differentiate into all 220 types of specialised cells which comprise the human body. And then there are the so-called adult stem cells, which are responsible for regeneration of damaged tissues and organs at that particular site. These cells are very unusual in that they're capable of what we call self-renewal and differentiation. That means that when we culture them in vivo, they have almost an indefinite lifespan, but they also have an inordinate capacity to differentiate into specific types of cells given the right environment. Now, there are many different types and sources of stem cells. Most likely, I would say now, we understand that there's unlimited sources. No matter, you will be able to derive a stem cell from pretty much any tissue or organ that you wish to look at. But for the purpose of today, let's just consider that we're going to focus most of our attention on dental stem cells and the so-called induced pluripotent stem cells. By way of history, we were involved in a large multi-centre study, which then resulted in the first report in Lancet reporting on the initial isolation and characterisation of multipotent stem cells from the human periodontal ligament, and this was now published some 10 years ago. So the stage really from here was set for things to move forward, where we had shown that the cells existed, they could be differentiated, they could be reimplanted in an animal model and led to the formation of new cementum bone and ligament. Since those studies now, as I said, not only in the whole body can you get stem cells, but pretty much apart from enamel, you can get stem cells from any aspect of the dental tissues and the surrounding tissue. So you can see from this slide now, the field has got very complex in terms of isolating any number of cells from the pulp, the gingiva, the PDL, the alveolar bone, the apical papilla, the surrounding mucosa.